we talked about multiplying powers. Today we're talking about dividing powers. Okay? Now, when you reduce fractions, you know that if a number like 3 over 6 can be reduced to 1 over 2, 3/6 is 1/2. If you divide a number by itself on the top line, what does it become? 3 divided by 3 is 3 divided by 3, 1. Yeah, yep. Or any number divided by itself is 1. A divided by A is also 1, right? What we're doing is subtracting their exponents when we get that. Okay? And we're going to be doing that with variables today. So, dividing powers. We're going to divide powers with the same base. When we divide powers with the same base, you can find the answer by subtracting the exponents. That helps you to simplify it. And then, sometimes, you're going to end up with all of the letters, all of the variables crossed out. And then, you have to remember this, that any number to the 0 power equals 1. Any number to the 0 power is 1. Okay? So, let's look at an example of dividing powers with the same base. This one is given to you. A to the 4th divided by A to the 6th. Okay? Now, if you write that out in expanded form, you would write A times A times A times A to the 4th power, over A times A times A times A times A times A to the 6th power. Right? Then, for any number that's the same on the top and the bottom, you can factor out an A, or you can cross it out and write 1. Because A divided by A is 1, A divided by A is 1, A divided by A is 1, A divided by A is 1. So all of these just become 1s. What are you left with on the top line? 1 times 1 times 1 times 1, which is 1. And on the bottom line, 1 times 1 times 1 times 1 is 1 times A times A. There's 2 A's left over, isn't there? What's A times A? A squared. So we can simplify A to the 4th over A to the 6th as 1 over A to the 2nd. 1 over A squared. When you cancel everything out, that's what's left over, isn't it? Right? Show me slant. Right?
Yes.
Yeah, okay, good. Let's look at some examples. This one is A to the 3rd over A to the 3rd. Well, if we were to write this out, we would get A, all the A's would be crossed out, right? Or A to the 3 minus 3. When we are dividing powers with the same base, you can subtract the exponents. Subtract the exponents of the same base. A to the 0 power. What's A to the 0 power? 1. Right, so the answer to this is 1. Does everybody see that?
Yeah.
Can you think of that, how that would look in expanded form?
Yes.
Now, when we had A's left over on the bottom line, if we were to take this example, A to the 4th and A to the 6th, and write it out as A to the 4 minus 6, what would we get? What's 4 minus 6? Nikki? Negative 2, right. This would be A to the negative 2. right? Now, what does that mean? Well, it means 1 over a to the 2. It means that we're going to take the a to the negative second power and we can put it into the denominator. Or it's the reciprocal of a squared. The reciprocal of a squared is a to the negative second power. Okay? So look at this one. N to the negative third power is the same as 1 over n to the third power. Okay? You see that? N to the negative third is the same as 1 over n to the third. Just like we had over here, a to the negative second power is the same as 1 over a to the second power. So you take, when you have a negative 1, move it to the opposite side of the division bar. That's what that says here. You move a power from the top to the other side of the division bar, to the bottom, the power changes from positive to negative. They're reciprocals, is what that means. Okay? Now, here's another example. 7 to the 8th power over 7 to the 2nd power. 7 to the 8 minus 2 is 7 to the 6th power, right? Here's one with letters. X to the 5th over x to the 1st. Well, if we canceled out all of the x's, there'd be 0 left on the bottom. Any number to the 0 power is 1, right? Show me slant. 1? Yeah. So, x to the 5th minus 1 is x to the 4th. That equals x to the 4th power. Okay? Let's go to your assignment for today. Number 2 on page 217. H to the 6th over h to the 2nd. I want you to write it this way. First, copy the problem. H to the 6th over h to the 2nd. There's 217. Then, write it as h to the 6 minus 2, which is h to the 4th power. Write it like that.
I forgot my assignment in my picture table.
Okay. Number 4. This is the actual assignment. That's why I said, let's do a couple from your assignment. Wow. Number 4. 10b to the 8th power over 2b to the 6th power. Over 2b to the 6th power. Okay. Now, first, can we reduce the numbers?
Yeah.
What can we factor out of both numbers? Dylan?
The bees.
No, the numbers.
That's not a number.
Oh.
Ishan? We can't factor a 5 out of 2. We can factor out a 2 and be left with the 5. So what we're doing is factoring out the 2. And we can factor out 1, 2 out of 2. So 10 over 2 is 5 over 1. How many 2's are there in the number 2? There's 1. How many 2's are there in the number 10? 5. Dividing both of these numbers by 2. Okay? In algebra terms, we think of it as factoring out. Okay? We can factor out 6 b's out of each of these, right? That's what we're doing when we're dividing. So, this is 5b to the 8 minus 6. that is, we can simplify that to 5b. What's 8 minus 6? Second power, yeah, squared. I thought you said 7 too. Okay, so simplify the numbers and then simplify the exponents. Let's skip to, let's skip to number 16. 2y to the third over 8y to the third. 2y to the third over 8y to the third. Henry?
You take away 2.
Yeah, we can factor a 2 out of the 2 and 8. So we're left with 1 and 4. So simplify this to y, whoops, I'm sorry, 2, 1 over 4, and then y to the 3 minus 3, which is y to the 0 power, which is 1. Yeah. So 1/4 times 1, which is just 1/4. Yep. Another way to do this is to cross off both y to the thirds and just write 1. We know that y to the third over y to the third is 1. Okay. How about with more than one variable? How about one like, let's see, number 26. It says write each expression without a fraction bar. Number 26. Whoops. Somebody read that question for me. Dylan?
Okay, a to the second power, and then b to the fourth power, and then a little line things,
That's,
your division
you're right.
sign.
Over, yep, or the division sign.
And then a to the eighth power, and then b to the second.
Good. Okay. So, how many a's can we factor out? We can factor out 2. So we're left with just the number 1 up here, right? And when we cross out a to the 8th, how many are left? No. Yeah, it's a to the, this is a to the second minus 8, which is a to the negative 6. Right? So we could write a to the 6th right here. There's 6 left if we take away 2. Right? Now, how many b's can we factor out? Chase. 2 out of each. Right? So we're left with just the number 1 here. Because b squared, factor out b squared, and that's 1. And b to the what? What's left? B squared is left. Yep. Now it says to write these without the fraction bar. Well, if a to the 6th is under the fraction bar in the denominator, how can we write that above the bar? How can we write it as its reciprocal? Or not as its reciprocal, but its reciprocal would be a to the 6th power. So if we write it above the bar, it's a to the negative 6th power. Okay, remember what we wrote right here? If you move a power from the bottom line, from the bottom of the division bar to the other side, you write it as its negative. Like a to the negative 2nd power, we wrote as 1 over a to the positive 2nd power. We moved it to the bottom of the division bar. Or n to the negative 3rd power is the same as 1 over n to the positive 3rd power. Okay? By moving this from a to the 6th on the bottom of the division bar to the top, it's a to the negative 6th. Then, this is still there, b to the 2nd power. Everything else is just 1. See, 1 on the top line, 1 on the bottom line. Right? So this answer is the same as 1 over, 1 b squared over a to the 6th times 1, isn't it? Except we just moved the a to the 6th power above or to the top line, so we didn't have to write the division sign, that division bar. Okay, these two answers are equal, they mean the same thing, but this is written without the division sign. This is written without this division sign. Okay? Alright, for your assignment, I want you to do 2 through 34 on page 217. Evens. 2 through 34 evens. Okay?
Hey.